It's a mystery as old as this forest. Cries in the night from a source unknown.
We've been able to compare this sound with the obvious animals that it might be.
Images captured on film.
It came out and looked me right in the eye from behind that bush.
Footprints and fingerprints unknown to scientists.
This is unlike anything I've ever examined before.
All this evidence points to a legend known as Sasquatch. Or does it?
We'll generate a DNA sequence that will identify the source of the hair somewhere on the tree of life.
Can these clues lead scientists to the definitive discovery of a new species?
This unusual combination of characteristics is going to give some important insights.
And a complete examination of possibly the most compelling piece of evidence. A two-third impression of what many people think is the body of a Sasquatch.
So this is one of the first times we may have proof of a North American ape.
And we will use the latest technology to determine the size, speed, and stride of a film subject to determine if it is within the human range.
And maybe get some answers on this project.
Or can this same evidence prove it is all a hoax?
That's when my jaw dropped, and I remember just saying, that's not a man.
For the first time, real scientists, professionals, and forensic experts will put the Sasquatch mystery under the microscope in Legend Meets Science. Are these creatures merely an artifact of human imaginations?
He was right behind that small pine tree, right? I'm freaked. I'm scared.
Or a series of persistent hoaxes? Or a highly elusive, intelligent ape species that has avoided our grasp throughout our history? We will attempt to shed new light on this age-old mystery, and hopefully we'll crack the case. With no Sasquatch body to examine, science must look to other clues and evidence to prove or debunk the Sasquatch legend. We do know that a huge upright primate species did exist in the past, and it fit the descriptions of modern-day Sasquatches. Meet Gigantopithecus blackie, an ape so large it is hard to fathom that it once walked the earth alongside early man.
We know from the fossil evidence that Gigantopithecus lived side by side with Homo erectus. We don't know whether Homo erectus hunted Gigantopithecus or hid from the giant ape. Here is a cast of the largest jaw of Gigantopithecus with the ascending rami restored. People are always amazed to think that an ape this large ever lived.
While scientists know of almost 2 million species of animals on Earth, some suspect there may be as many as 10 million they don't know about. One possible new species, a North American ape, may be familiar to many, but only as a popular legend. The creatures known to Native Americans as Sasquatches, wild men, known as Yeti or Bigfoot. And with over 400 sightings each year and hundreds of footprint finds, this mystery continues to provide us with clues about a possible uncatalogued animal. Dr. George Schaller is considered one of the world's foremost experts on non-human primates. His pioneering studies of wild great ape populations led the way for field scientists such as Diane Fossey and Jane Goodall. He knows the Sasquatch mystery all too well.
Finding another species that's more closely related than any other to human beings would have a tremendous impact on humanity. Now, about once a year, a new primate has been discovered. We have gorillas, 2 species of chimps, and orangutan. Those are the closest living relatives. Well, Sasquatch, if it exists, might be even closer than them. There has been, over the years, so much circumstantial evidence. To me, I still feel that there's something there that is worth pursuing. And the more you can analyze it, the better. If the analyses show that there's something really unique about this material, and we can eliminate the myths one way or another, then it will open up whole new vistas for humanity.
One type of evidence in abundance is footprints. Casts of alleged Sasquatch footprints have been made from impressions all over the world. These prints provide experts with a well-known clue: dermal ridges, better known as fingerprints. One of the best fingerprint experts in America is crime scene investigator Jimmy Chilcutt. He will examine casts of footprints for dermal ridge evidence to determine whether they were faked or whether they were caused by a known or unknown species.
My testimony puts people in jail, so I have to be very, very careful and very professional when I match a latent fingerprint to an ink print.
Chilcutt has fingerprinted every known great ape species. He'll use his unique skill and his catalog of primate material to examine and compare the best Sasquatch footprint casts available.
As a latent fingerprint examiner, I'm one of the few who is an expert in primate fingerprints, trying to determine gender and race through fingerprints, because primates don't interbreed like humans do, and try to find the key that would unlock the secrets of human prints. I will apply the same science to the Sasquatch castings as I do to a latent fingerprint lifted from a crime scene. My study group consisted of over 100 alleged Sasquatch castings. And some of these castings were cast as much as 20 years apart. And once I established the texture and the pattern flow of this animal, I was able to look at the other castings and know what I was looking at.
At the very least, Chilcutt should be able to tell us whether the prints are from a real animal or a clever forgery.
If this animal is walking through the wilderness, he's bound to come across rocks and rough terrain, which will cut the bottom of his foot. As the wound heals, the ridges curl inward toward the scar. So to authenticate any scar on these castings, I will be looking for that same characteristic. In human footprints, the ridges run horizontally across the width of the foot. On primates, the ridges run diagonally. On this casting, the ridges run vertically down the side of the foot. The ridges on this cast are about twice the thickness of a human print. Now, these casts were cast 20 years apart and hundreds of miles apart, yet they have the same ridge texture and ridge flow pattern.
If casts of footprints are telling, then the cast of an entire lower torso would surely be groundbreaking. In September of 2000, an expedition was conducted in a remote corner of the Pacific Northwest by the Bigfoot Field Researchers Organization.
And we used some techniques to try and lure in a Sasquatch.
A team of trackers, scientists, and other experts, including investigator Richard Knoll. They discovered a strange imprint and cast of what may be the most compelling physical evidence to date.
At the time, we had no idea the magnitude of what we had found.
I think the most distinctive feature of this whole thing for me is right here, which looks to be possibly a heel imprint with a calcaneal tendon, and the suggestion of friction skin or dermal ridges here.
This should be the dermatoglyphics.
Right.
Right here.
This extraordinary piece of evidence shows impressions from the body of a large animal and may also contain hair samples. The question for science? Were these unusual large impressions created by a known or unknown species? Richard Knoll and the Bigfoot Field Researchers Organization wanted answers, so they sought the opinions of some prominent anthropologists.
First and foremost, we need to get very accurate proportions.
Dr. Jeff Meldrum, a highly respected anthropologist from Idaho State University, led the initial probe of the evidence.
I'm very interested, too, in the pattern of the hair flow on the various contact surfaces.
I'd like to take a look at the comparative depth of all the prints to see which surfaces are imprinting deeper.
and Dr. Esteban Sarmiento from the American Museum of Natural History in New York City.
What's the material like? And finally, I'd like to collect hairs from the different areas. The surfaces that we believe belong to one might belong to more than one animal.
By world-renowned primate anatomy expert Dr. Darius Swindler.
An extra cast made of this area of the Achilles tendon.
The heel impressions in the cast are the parts that intrigue Swindler the most. It is an area of primate anatomy that he understands with authority.
It is a combination of two muscles, the gastrocnemius and the soleus. In humans, about a third of the way down the leg, they fuse together to form the tendon of Achilles that then continues on down and attaches to the back end of the heel, or the calcaneus. This is a well-pronounced, well-developed tendon of Achilles.
If this is a heel, it's pretty large, a lot larger than a human. The animal must have been heavy enough that it was able to wipe out all of the other prints that were there before it.
Dr. Sarmiento's forensic experience led him to come up with more questions than answers.
You want to see if there's more than one animal responsible for the body print.
And the hair yields in comparison to hairs from known animals.
They're definitely not human hair. We're going to find out who committed the crime.
Their combined expertise in primate behavior and anatomy will help in unraveling the mystery of the Skookum cast.
This big area here, it has to be an animal impression of the body. And the question now we have is, what part of the body?
Not all evidence of the Sasquatch's existence is made of plaster.
You don't see him right
Some of
there?
the most compelling evidence can be found in rare clips of film and video footage.
Oh, there he goes.
Jesus.
One such video was recorded by Lori Pate in 1996 while on a fishing trip with her family and friends in Northeast Washington. This video clip, known as the Memorial Day footage, shows a hair-covered upright figure running across a mountainside.
Okay, where the, see where the bush is? And then there's a small pine tree? And then he was right behind that small pine tree, right?
While not greatly detailed, it has certain compelling aspects to it, including the movement and the high speed at which the figure appears to move across the rugged terrain.
He's off.
All on video.
The most famous piece of film footage was shot in 1967 by Roger Patterson and Bob Gimlin. They recorded the footage in a remote valley in Northern California. The footage shows what appears to be a female Sasquatch retreating back into the forest. Is it a hoax or the best film evidence ever recorded? In 1994, another video camera briefly captured a similar figure in the Blue Mountains of eastern Washington state. Paul Freeman, a Forest Service employee at the time, had been noticing telltale footprints of a Sasquatch in the area. This time he had his camera ready and captured something extraordinary.
The pendular movement of the lower limbs allows us to calculate height from a frequency, so the length of legs from frequency in most mammals or most animals. When I compare this footage, the Memorial Day footage, in this case, from an estimate, you can tell that this isn't a very tall individual, maybe between 5'8", 5'9", and 6'3". The Freeman film, like all of the other films, doesn't have much resolution. But one of the things that is different is the size of the stride and also its frequency, which seems to be very slow. If you look at its head bob, it also seems to move rather slowly, and it gives you the impression that the animal is rather large. I would have to sit on the fence given the resolution. It's very difficult to prove, with certainty that this creature is real or is a man in a monkey suit. The detail just isn't there.
Some experts are up to the challenge of digging deeper for answers about these alleged Sasquatch images. Recent advances in 3D modeling and animation provide new ways of viewing and studying subjects captured with moving images.
About a couple weeks ago, I got some footage from Dr. Jeff Meldrum that he had been studying recently. He said that he was noticing some interesting gaits here on the profile of the actual creature. The actual knees kind of do this circular motion. They kind of knock inward and then they kind of walleye outward.
Ruben Steindorf of Vision Realm, an animator and expert in animating bone construction, is intrigued by this mystery. He is helping scientists reevaluate the Patterson footage to see if the stride and gait of the creature could even be accomplished by a man in a monkey suit.
Instead of using regular kinematics as I would for the regular human anatomy, I'm actually using inverse kinematics so that I can recreate the alleged Sasquatch anatomy. If the joints actually move based on my inverse kinematics, then they actually make sense in the physical world.
The next step is for Steindorf to carefully apply motion tracking to the figure, anchoring and locking the joints such as the knees and ankles.
Trying to lock to several points inside the footage here so that when I actually recreate the gait that I'm seeing on the footage, I can actually match that gait and see if it's accurate.
A time-consuming process, but one that may offer new clues as to the identity of the creature. A clue anxiously awaited by our biomechanics experts. Some of the most interesting evidence in clips of footage lies not in the film subject itself, but in the backgrounds in which they walk. Height, stride, bulk, and speed can all be measured by comparing the moving animal to fixed objects seen in the backgrounds.
If we can compare the size of the rocks and the distance between the rocks to the size of the creature, we'll be able to make an accurate comparison and determine the creature's stride and height.
The backgrounds of the Patterson and Freeman footage have changed dramatically over the years, due to encroaching forest growth or human activity. However, the site of the Memorial Day footage remains much as it did when the footage was recorded in 1996.
Lori, grab the camcorder. What kind of man can run across a hill like that?
Our goal is to determine if the creature is in fact moving at a rate of speed too fast for a human.
That's not a man.
Well, maybe it'll come back out. Looks like a Bigfoot to me.
The Memorial Day footage was shot by Lori and Owen Pate as they vacationed in the Pacific Northwest. At first, they were unsure of what they saw.
I think we were all in denial.
What was it?
We weren't even really sure what we had seen at that point.
Owen told me to go get the movie camera. He told me that they had just seen a Bigfoot up on the hill, and I just turned the camera on and was taking a picture of it running across, and I just thought, wow.
Tom Lyons, another witness, grabbed his binoculars and got a better look at the creature running across a steep valley at a speed that seemed inhuman.
Okay, I saw it come out of the woods and start running across, and it was just far enough away where I wasn't quite sure what I was seeing, you know, only it was big and tall. And I had my binoculars in the camper. I turned around, grabbed them, and put the binoculars on it, and I saw about the last 3 seconds of it walking into the timber, and that's when my jaw dropped, and I remember just saying, that's not a man. I could see the long hair coming off the bottom of the arm. That's what really caught my eye. And then it was gone.
Seeing can be believing, but measurements will not lie. These measurements will allow an elite team of professional forensic analysts and surveyors to determine much more about the figure originally observed and recorded by the Pates. The forensic team consists of 5 measuring experts, each with his own skills and disciplines in the art of forensic reconstruction. Doug Devine of Pacific Survey Supply brings to the table a host of high-tech surveying and measuring equipment.
This is going to be probably one of the greatest projects as far as equipment goes that has ever taken place. We've got everything from robotic total stations to laser speed guns, the Cyrex LiDAR imaging system that'll actually create a 3-dimensional model of the area that the creature was sighted. We're going to establish control that will show where the original filming took place, the first time it was spotted, the last time. We'll be able to ascertain heights, speeds, and maybe get some answers.
Accuracy is everything.
It's better to have too much data than not enough.
If all goes well, in a matter of days, the team will have some preliminary results.
We'll be able to find out how big this thing really is.
Step 1 is difficult. The team must first determine the path the figure took as it ran. It is on this path that everything related to speed and height depends. Landmarks in the video are carefully noted by the team. The first pass on staking out the pathway is the starting point for determining where the figure ran. This determination will greatly affect all of the results. They must move each reference post carefully and repeatedly before a consensus is reached.
Bill, that looks just perfect. Good, I think it's right on.
Thank you.
Although the figure looks large, an optical illusion caused by the apparent steep slope on the side of the mountain can fool even the most experienced observer. Time and lots of accurate measurements will tell. Once they determine the creature's path, the team scans the entire mountainside with a 3D radar system. The data accumulated by this system represents more than what 100 surveyors could gather in a month's time using traditional surveying instruments and methods. With this device, over 300 million data points will be gathered from various control areas within a matter of hours.
This technology is basically giving us information at the rate of a jet plane going around the world instead of a hiker.
I'm all done with this setup, so we can go ahead and take the green tripod and lower it down below the yellow setup.
Okay, we'll move those over.
Challenging the film subject to a race on this very steep and soft terrain would be difficult, but it is one way to measure the running speed of the figure. A visual comparison will also give subtle clues as to the authenticity of the image. Add rocks, loose soil, and an abundance of Pacific diamondback rattlesnakes, and this race will prove to be downright dangerous. Derek Pryor is a 3-time All-American sprinter from Washington State University. He prepares for a potentially historic race.
If I fell, I'd probably break an ankle and roll down that hill and get pretty scraped up. Wouldn't feel good. This is all new for me.
The team fits Derek with a laser tracking device and a gimbal GPS unit.
I don't know, I figure I'm faster than about 99% of the rest of the world here, so I seriously doubt some yahoo in a gorilla suit came running through here faster than me. So I'm sure I'll smoke this thing.
Okay, well, you're set to go.
All right, let's do it.
This backpack will allow the researchers to gather information such as speed, vertical movement, and path deviation during the race.
Yeah, we just finished a practice run. I think it went pretty good. It was pretty fast. Now we got the backpack strapped on. I anticipate this will probably slow me down a little bit. It messes up my balance quite a bit, especially when I'm changing directions down here.
If he falls, it'd be an expensive fall.
Measuring may help quantify the reality of this animal. But is this Memorial Day creature's behavior consistent with that of a real animal's reaction to its surroundings? Dr. Sarmiento knows the behavior of wild primates and how they adapt to subtle changes in their environment.
When I compare this footage, the Memorial Day footage, to the Patterson-Gimlin, one of the things I see is that the behavior of the Memorial Day footage, the individual seems to be a lot more natural. He enters an open field in a run, and then he goes behind the hill and he tries to hide. And I guess there he can slow up because he knows he's reached safety by the time he reaches the forest.
From Richard Knowles' perspective, running across loose rocks on the side of a mountain while wearing a fur costume would be impossible.
What he's doing right now is crazy. Anybody that would go up there in a suit and run that is crazy.
The start of the race is close at hand. Pryor's legs are warm and ready. The Pates and their friends watch and wait as the laser tracking device locks on the sprinter.
Locked on, ready to go.
The robot will use its concentrated light beam and high-tech receiver to monitor every movement, vertical and horizontal. The runner is ready. Feet and hands dig in for his launch. The countdown begins.
You think Derek can win this race?
7. I don't know. He's pretty fast.
5,
We'll see.
4, 3, 2, 1. Ready, set, go.
The surveyors will clock his speed from the moment he breaks past the first reference point. Pryor takes a fall, and the team is worried that he may have injured himself on the jagged rocks.
It's rainy up here. The rain came down and it's slippery. He slipped on a piece of weed or grass.
In short order, Pryor's assistant assures the team all is well. Luckily, Pryor slipped and fell in a rock-free grassy patch. They restart the race and finally capture some usable data as Pryor successfully completes the race without falling. In a few weeks, the team will calculate and recalculate the new data from the Memorial Day creature footage. This will happen until the team reaches a consensus. The raw data is now in the can, and this forensic team now has their work cut out for them. There's no telling what the results may be. The forensic work on the Memorial Day film subject may be the most high-tech Bigfoot film reconstruction, but it was not the first. Back in 1968, just one short year after the Patterson-Gimlin footage was taken, pioneering Bigfoot researcher John Green had the foresight to do his own forensic reconstruction at the Bluff Creek film site. This was not a high-tech measuring effort. Green's simple plan was to first determine the path and then have his 6'5" friend Jim McLaren walk the route at roughly the same speed and film it with a similar 16mm camera from the precise position in the creek bed. With the backgrounds now overlaid precisely, it offers good reference and a unique perspective as to the actual size of the Patterson creature and gives visual clues as to the authenticity of this footage. Behavioral parallels of great apes and reported behaviors of Sasquatches provide important insights. John Bindernagel is a wildlife biologist in British Columbia.
As early as 1846, stone throwing by Sasquatches was reported here in British Columbia. That's a very common element of chimpanzee intimidation behavior that wasn't really reported until the 1960s. What it suggests to us is similarities between chimpanzees and Sasquatches and a possible relationship between these two animals. Other similarities between Sasquatch reports and reports of chimpanzees and gorillas include behavioral elements such as chest beating, stick wielding, and loud vocalizations.
Dr. Robert Benson believes in evidence. The Texas A&M Corpus Christi physics professor and director of the university's Center for Bioacoustics does not yet believe in Sasquatches, but he is open-minded, and he's interested in examining one of the many alleged North American ape recordings that exist.
Look at the screen. This is really interesting. Get some ideas about where this may have come from in terms of what animal made it, and so that's lucky. Even though the sound is not great, it gives us enough to work with. Right here, you will notice these darker lines. These are what we refer to as the formants. They have to do with the resonances of the vocal tract.
Benson regularly studies natural sounds, ranging from birds to marine mammals. He can identify species by their sounds alone, using his own ears and the help of a sophisticated computer.
I think with the experience I've had listening to animal sounds that we could rule out barred owl as a possibility. We could rule out elk, wolf, and coyote. With the analysis, we might be able to actually rule out some other animals that are not native to the United States.
For known species, sound evidence can reliably indicate population densities, mating behaviors, and locations of known species. But what about unidentified sounds, such as the loud, unidentified howls and screams that are often attributed to Sasquatches?
I believe that a thin population of some secretive animal could actually benefit from a long-range vocalization, as you hear on these tapes.
Dr. Benson knows there is a wide range of possibilities for sounds heard in a forest, including the possibility of a hoax. Benson knows this last possibility is relatively unlikely, considering the number of potential natural causes.
Okay, start it. Stop. Enhance it.
My first inclination listening to this recording is that it's similar to a woof, but it's more mechanical, like a siren.
Actually, it does sound a bit mechanical, but if we do the analysis of the formant structure, we might be able to rule out a mechanical source as well.
To his surprise, Benson's initial pass at the recordings doesn't reveal a probable answer. Further comparisons will allow him to analyze the sounds in various ways.
We've been able to compare this sound with the obvious animals that it might be. In our analysis so far, it does not seem that this source fits into those groups.
While Sasquatch sound recordings provide their own clues, thousands of eyewitness accounts of large, hairy, upright walking creatures may be just cases of misidentification. Many witnesses' first impression is that they're seeing a bear. But when the animal begins to walk or run, impressions quickly change. Is the two-legged gait and profile of a bear even comparable with the Sasquatch description?
Bears are probably the most human-like of the North American mammals. They have basically the same musculature as a person. They have about the same skeleton, except they lack the collarbone. They can walk upright. They look like a slope-shouldered human, but they don't usually walk upright very far, only a few steps, unless they have severe injuries to their front legs. So if a person sees a broad-shouldered animal walking across the road on its hind legs, it's probably not a bear.
Vertical and horizontal patterns and track stride also offer clues to potential misidentifications.
It seems to me that the footprints constitute the largest and most consistent body of data bearing on this question. And as such, they really deserve a concerted, systematic evaluation. In instances where we have successive footprints in a given trackway, I've been able to note flexion and extension of the toes, variation in toe position, and interaction of the foot with substrate under varying conditions.
I'll also be looking for dynamic signatures that show this is a living footprint as opposed to something static. In this instance, we have the good fortune of a pair of tracks that are successive in a single trackway. And by comparing then the shapes and conformation of the toes, we can say a lot. For example, here, not only are the toe pads differing in dimensions, although clearly the same foot, even the toe spread is distinct from one footprint to the other. We're looking very closely at the surface of the footprint to see if there are any latent features, skin detail or skin ridge patterns that show up in the track. We'll be looking for landmark features that indicate the points of jointedness, where the foot bones articulate with one another and how they interact to form a functional unit. The overall appearance of the footprint can also be used to compare tracings from one location to another to see if there are repeat appearances of an identifiable individual. And this overall picture will help us to assess the function and compare that to models of human foot function as well as non-human primates and even fossil hominid tracks of early bipedal human ancestors.
But what if an animal that left a set of alleged Sasquatch footprints was also filmed? Can the two pieces of evidence be linked together to mutually strengthen the case for authenticity? This exact scenario happened in 1967. Steindorf's 3D modeling of the figure in the Patterson footage is now complete. The animation will be sent to Dr. Meldrum in Idaho, enabling a first-time glimpse of the Patterson creature from almost any point of view.
With this animation now, I'll be able to not only visualize, but more importantly, quantify aspects of this peculiar bent-kneed gait on a flexible flat foot. I've also noticed right away that there's an interesting rotation of the leg and foot that's not typical of a modern human gait. If this is in fact a real animal, this unusual combination of characteristics is going to give some important insights into the evolutionary history of bipedalism. In fact, it very well may challenge some of the preconceptions that we have. These features correlate, in fact, with the very types of adaptations that we would expect of a biped that's living in rugged, mountainous forests.
For additional opinions on these anatomical perspectives, Dr. Meldrum consults with Andrew Nelson of the Center for Motion Analysis and Biomechanics at Idaho State University. Nelson is able to view the Patterson figure from yet another specialized perspective. While studying the Patterson footage, a large visible bulge is seen on the leg of the subject.
Right there, stop there, and you can actually go one frame forward.
While inconclusive, it does in fact raise additional questions about how a fake monkey suit could be constructed with such detail over 35 years ago.
It could be some sort of traumatic pathology, a rupture of the IT or iliotibial band, allowing the underlying muscle to selectively bulge through in that area.
First of all, I would say that that would be characteristic of at least a partial rupture of part of the quadriceps. There's also the IT band, or the iliotibial band, that runs through the area also. You know, a creature that would have that type of a rupture would certainly have compromised gait of some sort.
Working together from fresh scientific perspectives, Meldrum, Nelson, and other scientists will be able to form new scientifically supportable conclusions about this footage. Scientists often look for patterns in statistical data. Patterns in biological data form the basis for many scientific conclusions about organisms and populations. In the animal world, height, weight, and other measurable characteristics will tend to fall in a bell curve pattern when charted on a graph. Finding these patterns in the data from Sasquatch evidence can be a useful way to determine if the evidence points to a living, breeding population or a series of hoaxes. This is what interests Dr. Henner Fehrenbach, a retired scientist from the Oregon Regional Primate Research Center.
I'm going to take the data for foot lengths as an example and represent them as a histogram. And now I have the raw data for the length of the foot and the width of the foot. I will combine these two into a ratio that will tell me how the width of the foot in relation to the length changes with increasing size of the animal, because we do have information on that particular aspect from human feet that get longer and narrower as they get bigger. Study of the shape of these histograms then will tell you whether either they came from totally fictitious data, in which case there's going to be no order to them, or whether they came from a living population, in which case the curve approximates a bell shape.
While statistical data can be used to predict likelihoods, DNA evidence is considered a more exact science. DNA evidence is considered almost 100% conclusive in determining lineage or species identification. Dr. Craig Newton of BC Research in Vancouver, British Columbia, is an expert in mitochondrial sequencing. He is searching for the molecular goldmine, using evidence collected from 2 separate locations. The procedures for DNA extraction require thoroughness and patience. Every step must be performed flawlessly.
These are the 3 samples that I received from the BFRO. These ones here are the hair samples that came from the Skookum cast. Over here is the apple slice that came from the bait at the Skookum site. And then we have a 3rd sample which corresponds to a stool that we wish to try to identify by DNA-based technologies.
Any mistakes or contamination along the way will only yield useless results.
Now I'm going to add the DNA extraction buffer to the hair sample. And if we get a DNA sample out of it, and if it's free of contamination, we'll generate a DNA sequence that will identify the source of the hair somewhere on the tree of life, either between humans and primates or between other organisms in the forest. It's all in the DNA. So now I'm going to pour an agarose gel to see if we got any DNA out of that hair.
DNA analysis is a science of new frontiers, with protocols and techniques that are rapidly evolving and improving.
Melt the agarose. Now we're going to add the dye.
In the best case scenario, Dr. Newton will extract a DNA sequence that does not match any known species. It's more challenging than typical analysis because there are no reference samples to work from.
Now we have lots of circumstantial evidence that these hairs are about as authentic a sample as you're going to get. My goal with this work is to get just as much believable data as I can.
DNA is found either in the nucleus of a cell or in the mitochondria of a cell.
Now I'm preparing to run these samples out on a agarose gel, and these are nuclear DNA targets, which are probably my worst case scenario. I would much rather use mitochondrial DNA primers, but I don't have any that are universal. Well, I'm not too confident in these nuclear markers because of the contamination risk.
As Dr. Newton goes into the darkroom to expose his DNA film, he knows it's all or nothing.
Let's see if we got anything. Oh, there we go. There's Skookum Cast 1 hair, Skookum Cast 2 hair. There's the stool sample. So it looks like we can go ahead and do some sequencing.
Bits of plexiglass and pipettes, coupled with a broad knowledge of DNA extraction techniques, may ultimately separate myth from reality. Each of the scientists and experts who have delved into the Sasquatch mystery understand the importance of their efforts. They also understand their efforts represent separate pieces of a complex puzzle. What follows are 12 conclusions concerning the ongoing Sasquatch mystery. For the past hour, we have challenged our scientific team against the best alleged Sasquatch evidence available: DNA tests, fingerprinting, forensic audio analysis, anatomy examinations, and misidentification studies. Does this mystery need more research? This is a question you may have to answer for yourself. Our fingerprint expert, Police Officer Jimmy Chilcutt, examined many footprint casts in an effort to find dermal ridge patterns that point to other known primates, a hoax or a new species.
I've come to the following solid conclusion. Number one, that there is a great ape living in North America. Number two, that the friction ridges of this great ape are not human nor known primate. This conclusion may come as a shock to some people, but I stake my reputation on it.
Dr. Benson, a biological audio specialist from Texas A&M, analyzed recordings of alleged Sasquatch vocalizations to determine if they were from known animals or from an unknown creature.
In our analysis so far, it does not seem that this source fits into those groups. However, it does appear from the work we did comparing it to a human voice that it is probably primate, and that of course includes human as a possibility for the source.
Dr. Henner Fehrenbach studies patterns in the wild. Fehrenbach created a statistical database of recorded measurements taken from years of Sasquatch footprint evidence. These patterns might indicate the likelihood of an unknown species living amongst us.
The graphs that have emerged show generally a bell-shaped curve for foot length, as in this graph, as well as for heel width and ball width of the feet. Such a distribution would be expected to result from a living population rather than from fictitious data. These studies suggest that in all probability we may well have a large primate walking about in the North American forests.
The Memorial Day footage suggested that the creature was running at speeds across this rough terrain beyond human capabilities. Robert Taft and Associates and Pacific Survey's task was to provide exact data on size, speed, and gait of the creature.
In consideration of our field data, we're prepared to offer the following scientific conclusion.
First, the creature in the video has a height of 5.3 feet and has a leg length of 2.5 feet, quite similar to human proportions. Second, the creature is running at a speed of 8.56 miles per hour. Contrast this with our demonstration runner, who was able to negotiate the same path at 17.1 miles per hour, twice as fast as the creature. Third, we found the creature's stride to be 4.25 feet long. Derek Pryor, our runner, used a faster stride of 6.8 feet along the same path.
However, they were unable to explain the apparent protrusion that appears on the creature as it moves into the woods.
We are still puzzled by the fact that at the end of the tape, the creature appears to grow taller by 8 inches. If this is a real animal, one explanation is that it may be carrying a young animal that has climbed higher on its back. Further analysis will be necessary.
Dr. Craig Newton from BC Research in Vancouver, British Columbia, tested hair, saliva, and scat samples taken from several different sites, including the Skookum cast site. While DNA evidence can be the most conclusive, it can also be the most elusive.
Apple sample that we received that had saliva potentially in it, it refused to give any amplification product, so we couldn't conclude anything from that. The stool sample gave us lots of bacterial DNA, but trying to pull out a nuclear animal gene with it gave us nothing but contaminants. In the case of the Skookum cast hairs, again, both the sequences that we obtained were so human-like as to most likely be contaminants, either myself or the gatherers who collected these samples. So for the future, we need to make a much more concerted effort to rule out these things. They're technical details that just require more effort, more time, more commitment.
Dr. Dara Swindler, world-renowned retired professor of anatomy from Washington State. Dr. Sarmiento, an anatomy expert and primate behaviorist of the American Museum of Natural History, along with Dr. Jeff Meldrum, a physical anthropologist from Idaho State University, and Andrew Nelson of the Center for Motion Analysis and Biomechanics, were given the tasks of evaluating anatomical evidence left behind by the Skookum body imprint, footprints, the Patterson-Gimlin footage, and its 3D motion track reconstruction.
After analyzing the biomechanical issues of the Patterson footage, I find it very hard to believe that somebody in 1967 could have fabricated the intricacies as evidenced by the soft tissue irregularity that's seen on the upper leg. The study of biomechanics at that time was just far too primitive.
The Skookum impression shows clear evidence of animal activity, deer, elk, coyotes, but some of the imprints don't seem to belong to any other animal in the area that we know of. Now, some of these imprints, especially the heel-like imprint, is quite deep and must have belonged to a large animal of considerable weight.
Of that body cast of an animal, I have isolated this material here, which is the lower leg. This is the heel, and this large bump here, this ridge, is the Achilles tendon that it goes from the leg down to and attaches to the heel, and it helps us elevate our foot when we're walking. So in my opinion, the impression was not made by a deer, a bear, or an elk, or was it made artificially? The Skookum body cast is that of an unknown hominoid primate.
I've weighed and considered the evidence for a North American ape based on the Skookum body imprint, based on the Patterson film, based on hundreds of examined footprints. And I've now reached a point where it seems more incredible to consider all of this a series of spurious hoaxes spanning decades, if not centuries, than it is to entertain the likelihood that a new species of higher order ape may exist and may soon join the ranks of the family of primates.